Good day everyone, I am Loella Saraosos, and in this video, it is all about balancing chemical equations, or how do we balance a chemical equation. First, what is a balanced chemical equation? A balanced chemical equation is an equation where the number of atoms of each type in the reaction is the same on both reactants and product sides. Chemical equations, we have certain rules that are need to be followed. So we have here the rules for balancing chemical equation. First, we need to determine the correct formulas for all the reactants and products. Second is we need to write the formulas of the reactants on the left and the products on the right. Third is we need to count the number of atoms of each element in the reactants and products. Take note that a polyatomic ion that appears unchanged on both sides of the equation is counted as a single unit. And fourth, we need to balance the elements one at a time using coefficients. Coefficient is a small whole number that is written in front of a chemical formula in a chemical equation. And we must take note that when no coefficient is written, the coefficient is assumed to be 1. Also, you must not attempt to balance the equation by changing subscripts in chemical formulas. And the fifth rule is we need to check each atom or polyatomic ion to be sure that the equation is correctly balanced. And finally, make sure that all of the coefficients are in the lowest possible whole number ratios. So that's our rules for balancing chemical equations. Then we have here a sample chemical equation that we are going to balance, applying what we've learned earlier about balancing a chemical equation. So if we are going to read this sample chemical equation, it can be read as calcium chloride combined with sodium phosphate, and it will yield to calcium phosphate combined with sodium chloride. So in balancing this sample chemical equation, we are going to use the trial and error method. Trial and error method is a fundamental method of problem solving. It is characterized by repeated or varied attempts which are continued until success or until the person stops trying. So first, we need to write the elements or the formulas from the reactants and the products. So we have Ca or calcium and Cl or chloride, Na or sodium, and PO4, a polyatomic ion, which is phosphate. Next is we need to count the number of atoms or the subscripts of each element in the reactants and the product side. So first we are going to get the atoms or subscripts in the reactant side. So the subscript for our Ca or calcium is assumed to be 1 because we cannot see a number after the element. So we need to write 1. Next is we need to get the subscript for Cl or chloride. So we have here a subscript of 2. Then next is Na or the sodium. The subscript for sodium is, as you can see, we have here 3. And then we need to get the subscript for our phosphate or our polyatomic ion. So phosphate, our polyatomic ion, it is assumed to be 1. We cannot write 4 because 4 is the own subscript for oxygen. As a polyatomic ion, the subscript is assumed to be 1. After we after we get the subscript on our reactant side, we need to get the subscript for our product side. So the subscript of our calcium in our product side, we have here 3. And the subscript for our chloride, we have 1. It is assumed to be 1 because we cannot see any number after the element. And for our sodium, it is also 1. And for our phosphate, we have here 2. After this, we are going to multiply it by a coefficient. But as I've mentioned earlier, when you cannot see any number or coefficient, it is also assumed to be 1. So we have to multiply this all by 1. So let's multiply all the subscript to a coefficient. So we have 1 times 1, 1. So 1 times 2, 2. And 1 times 3, we have 3. 1 times 1, 1. And on the product side, we have 3 times 1, 3. 1 times 1 equals 1. 1 times 1, 1. 2 times 1, 2. After we get the result and multiplying the subscript by the coefficients, we need to check if each atom or the result is balanced. And as you can see, they are not balanced. So this is where we're going to use the trial and error method. We need to find other coefficients or numbers that would result the same or for it to be called balanced. So first, let us start in a first element. So we have the calcium. On the product side, we have a result of 3, and while the reactant side, we only have 1. So we need to change the reactant side for it to be the same result on the product side. So the number or coefficient that would result on a number 3 is 3. So we need to write down 3 on a coefficient, as a coefficient rather. So 1 times 3, it will result now to 3. So as you can see, it is now the same with the product. So we need to write 3 on a coefficient for the calcium. As we write 3 on a coefficient for calcium, the coefficient for chloride also is affected. We need to also substitute the coefficient of chloride into number 3. So we need to write here, or we need to change it into 3. So now we have 3 times 2. 3 times 2, it would result to number 6. So we have now 6. And while on the product side, the chloride only had 1. So we need to find a number that would result the same as on the reactant side. So we need to find a coefficient that would result into, if we multiplied it by 1, it would result to 6. So we are going to try 6. So 1 times 6, we now have 6. So we need to put 6 on our coefficient on for our chloride. So as you can see, the calcium and the chloride are now balanced. And as we change or put a 6 on a coefficient for chloride, the coefficient for sodium is also affected. We also need to change the coefficient for sodium. So, but only in our product side. So, we need to write 6 in here as it is affected. So we now have 1 times 6, it will result to 6. So as you can see, the sodium is still not balanced because on the reactant side we only have 3. So we need to find a coefficient for this one so that it would result to 6. So we are going to try now 2. So we have now 3 times 2, it would result to 6. So it is balanced. We can now consider it balanced. So we need to write here 2. So we wrote 2 for the coefficient of sodium, and same as the process earlier, in the sodium and chloride and calcium, the phosphate is also affected if we have changed we have put the 2 coefficients of sodium. So we are going to change the coefficient for phosphate. We have to write 2. So now we have 2 times 1. It would result to 2 for our phosphate. And then after this, we are going to check if all the result, or after we multiply their subscript by their new coefficients, if the result are the same, so for it to be called balanced. So let's start with calcium, and as you can see that both of their after we multiply their coefficients by their subscripts, they now have the same result, same as the chloride, the sodium, and also the phosphate. And for this to be complete, we still need to write 1 in here for their coefficient because we didn't change their coefficient. So now this is the result of balancing chemical equation for our sample chemical equation. So now this is our final answer, or the balanced chemical equation. And that's the end of our video, and I hope that you have learned something.